Hello, I'm Tim and I'm gonna try something different again in this video. I would like to talk about MEL, MEL. It stands for Maya Embedded Language, and it is a scripting language inside the 3D software Maya. I think it only works inside Maya, kind of like with the name, but it is, as far as I understand, a little based on Python. Um, so it's not too difficult. And since it is the language that Maya speaks, I think it's a good way to start programming. So first I'll start by showing what I'll be creating in this video. We're going to create this video window interface where we have a field to put in numbers, and we will create cylinders based on this field. Here they are. Then we'll add a sign deformer to this plane. There we go. And then we'll evaluate, and then the pillars can be animated using this controller, and they will go to the height. Go like this. It will go to the height of the plane, and if we change anything about this plane, we evaluate, the pillars adapt. It might not be the most useful thing, but it's a fun thing, and I think it's relatively simple. I'll be going over it very slowly, very carefully, and explaining everything, so it could be something fun to use. It's fun to do, at least. Not everything has to be that useful. Everything's a lesson, right? There we go. So if that's something you're up for, welcome, and I hope you enjoy it. So let's start with the beginning. In Maya, in order to work with scripts like MEL or Python, the easiest way is to open this window here, the script editor, and have a empty MEL tab, because what we'll be writing is MEL. So this is where we're going to be doing most of the exercise. I should start by explaining that I will not be demonstrating like how I work with it, like the work process that I have of troubleshooting and general creating things. I have already created the thing, the script, the little software, the little program, as you saw. So I'll just go through the individual code. So I already have the solution, so you'll just be able to follow along, and I'll explain what everything does, and in the end you'll have your own functioning version. Throughout this video, when you see me when I'm explaining and writing the code, you'll see me do these double dashes and then just write in plain text. This is called a note, and you can see how it's colored red. This double dash means that the code, this line, won't be evaluated, it won't be read. So this is where we leave notes for, well, mostly yourself or others, and explain what's happening, usually on the line below. So that can be very useful. Another thing we're going to use today is variables. A variable in MEL looks like this. It can have any name, but it comes after the $sign, and then usually there's an equal, 3, and you end with a semicolon. So whenever there's $sign my first variable, it will be the same as if I wrote 3. Of course there can be many different things after, but this is kind of like the basic, and it's a very useful tool when using in scripting, because that way we can have our code adapt and change, and I'll show you more when we get to it. We're also gonna use something called a for loop, and a for loop looks like this: command for, and then I use the variable I to dictate that it starts with 0 and stops when I is less than 5, and for every loop it adds 1. So and you can see that it prints the text hello world. The dash in the end makes it go to a new line. So if I execute this, we will see it print hello world 5 times up here. There we go. For loop's working. The way that it works is that when we evaluate, these locators, these green things, will go to the position of a specific point on this plane that we are deforming. So if we change it, press evaluate, they change height. And this height is then the maximum height of the pillars. And as this controller is moved along, they will blend. I'll show you in a minute, but the pillars will rise to that height. And I'm using that with a blend color that I'll show you now. So this is a blend color node. The script will create one for each cylinder. So we have the height goes in here from the first locator, and the second height is always 0, is at the bottom, and then the blend attribute is controlled with driven keys that I will explain in a minute, but it's controlled by this controller, the circle that you saw. So this will happen for each pillar. Driven keys is a way to bind the value of one thing to the value of another. So the value of this controller, this circle moving along, will be bound by the script to the blend node that we can blend the value of the joint into the locator, which will make the pillars rise. So as it goes, as you can see, as the controller goes up here, it has blended 100%, and the next pillar starts. So this is, so as 0, the blend is 100% not the locator, but just 0, and here blend at 1. The height is now 100% the joint, and this is what makes the pillars able to rise as slowly and as fast as you want, because you have these in-betweens. It is not an on and off switch. You can have all these in-between iterations. So I will now start creating the script, and as I said, I already have it, so I'll just go through it. This is not usually how I work with problem solving and testing. We already have the finished result, but I'd like to go through the code, and I would like to start with the interface that you saw. So let me start by adding some note for what I'm going to do. So I'm going to say here, look for the window we are about to create. I'm gonna make a little function, so if you execute the script twice, you won't have two interfaces. And we'll do this with the if command, and we go if, use this little, don't know what it's called. It is to the left of the 1 on my QWERTY. Is that an inquiry? On my keyboard. And then I'm going to use window, and with the flag EX, and pillars menu is going to be the name of the window that we are creating. So this is what that command does. It looks for the window called pillars menu. So if the window is open, close it. So then I'm going to use the delete UI command, and then the name pillars menu, semicolon. I think that's right. There we go. You can tell when something's off when the color isn't changed. So you can see this has to match. Okay. And then we tell the script to create a window. So we're going to use the window command, pillars, menu. There we go. But we need to put something, and I need to be consistent, otherwise it won't work. I need to be we need to put something in the window. So we're going to start by creating a frame layout. Put everything in a frame. So a frame layout is like if you imagine the rows on a spreadsheet or Excel document. But right now I'm just going to use a single one, and then we're going to go into details later. So frame layout, and I'm going to set the background color to 0.5, 0.5, 0.5, and I'm going to give this a label that is readable to humans. It's text, so I can use space. Press Control, mark every text marked like that, and finish off with a semicolon or break. Things with this line is called a flag, and if I spell them correctly, they'll work. They usually have two versions, like a full name version. I like to use them whenever I can. It just makes things easier to read. If I had just put in L, it would have worked just fine, but I like to use the full ones whenever I can. So now I'm going to use the rows that we talked about. We're going to make 5 rows. Sorry, I'm going to make 5 columns in my rows. I'm going to have like 5 spaces. Let's just create it. Make a row with 5 columns. There we go. That's with 1 L. Wouldn't really matter because it's in the node. So row, column, layout. And the number of columns is 5. There we go. First row is just a little space. This is how I like to do it. You can do pretty much how you like to, but it's just that I like to be just a little space in between the frame of the window and then where the actual button is going to be. So I just create a text that says nothing. It's just a space, really just to use it. So if you weren't going to use this method, you can use fewer columns. So here I create the integer fields because I can't have half a pillar. I'm using integer. As you know, that's a full number. So 1, 2, 3, 27, 105. Those are integer. 2.5 is not an integer. So I want to make that definition clear. Go here. Second column is the button. It's not a button. What am I doing? I'm gonna do an int field I'm going to set the width to 50. Not that too wide, I mean it's just going to be numbers. I'm going to start off with the value of 10, and then I'm going to give it a name so that I can look at it later. And I'm going to call it cylinder field. That's how I give it a name, and the name makes sense to me. Then I'm going to use a little space again, so third column is also space. Using the text command to add a little space. Doesn't really matter if there's a space between the end and the semicolon, I just prefer it that way. Then we're gonna have the button. So we made the fourth. Fourth button. The fourth column is the button with the command. There we go. So we're going to use this to create a button. We're going to tell that it's going to be 150 pixels wide. It's going to give it a label called create X cylinders. And then we're going to give it a command, because otherwise nothing will happen if you press the button, and the command is going to be called make cylinders. There we go. I'm going to finish my command like this. So inside like this. That way I can call upon it in my procedure later. And we're going to finish the fifth column. It's also space, so text with space in it. And that is one row with 5 columns, so we can now close the row. I'm going to do that with set parent dot dot semicolon is how that works. And then I'm gonna show the window that we have just created, and we do that with the show window command pillars menu semicolon. This should create a window with the integer field and a button. Let's see if it works. So I'm going to Control A and then press the enter all the way to the right to execute my command and not replace all of it. Seems like there's an error on line 29. So let's see what that is. Oh yeah, that's because it's a colon and not a semicolon. Let's try again. Frame layout. Interesting. Okay, it's because this needs to be capital L. Frame layout. There we go. I should have felt suspicious when I didn't change colors. Let's see if it works. No, row column layout. Is that because it's spelled wrong? It is spelled wrong. There should be an N in there. Row column. Nice word. Yeah, and it turned blue again. Okay, go down to number 14. Number of columns. Don't have a flag like that. It's probably spelled wrong again. It was spelled wrong. It's with an O at the beginning and not an U. Number of columns. There we go. Created your first interface. Well done. You can scale it down a bit, move it around. going to create an error because it can't find the procedures, but we have an integer field, the little spaces, and a button. So, well done. So why don't we continue with making the procedure, the command, or what you want to call it, that the thing that actually happens when we press this button that we just created. And the way that I like to organize my things is that the interface is at the bottom, and then the procedures comes in on top. So I'll just add a lot of lines here and then start at the top, because this is my top button. This is the first button, so that to me is going to be the first procedure. That's just how my brain works. So we're going to do a global procedure. This is what will happen when we press the button. So let me first make a note about it. Make cylinders procedure starts here. So we can have a global procedure, and it's called make cylinders. And we're going to use this one. That's how we start a procedure. And let me just check the name is correct. Make cylinders. Make cylinders. There we go. That should be it. Okay. So first I'm gonna read the number of cylinders. That's the number in the integer field that we created. 10, if I remember correctly. Just so we know how many cylinders we're gonna create. So we're gonna make a variable called cylinder number, and that is gonna have to be equal. Let me use this little sign here because we're going to use a code inside a code. We need this to identify or use a command inside a command, I should say, and we're going to use the command int field for integer field. Remember, before we used it to create the integer field, but since we're going to do something else, we use this little icon here. So integer field with the vary with the Q flag. When you use the Q flag, you ask for thing instead of dictate. So now I'm asking for the value of an integer field with the name cylinder field. Remember, that was the name that I gave it. I'm going to end with the same little mark found left to my number one button, to the number one key, and then end with semicolon. And I should be able to mark this. Yeah, I have the interface up, so I should be able to just mark this part and read it, and the result is 10. So there's a connection. Cool. Something you will see me do a lot in my scripts is select nothing. It's just a way to make sure that I know what is selected, and I like to do it. And it is actually select with the flag clear, like this. First thing we're going to do is create an empty group to put stuff in. You can see I haven't spelled it right. There we go, create empty group. That will create our empty group. And then I'm gonna rename the newly created group. So I'm gonna use the rename, and the name it's gonna have is gonna be null. When you don't give it a name, that's what it gets. We're gonna rename the null to control group. Gonna be it. And we're gonna create the circle controller. For that I'm going to use the circle command. Gonna give it the name pillars control. I'm gonna 0, 0, 0. These are all the standard settings that you get when you create a circle. 1, 1. Number of vertex and the position, all that stuff. I'm not gonna change it today, so I'm just gonna use diameter of 3. See, 2, 0, 8. And I'm gonna also add the object move command. There we go. So this is what I'm talking about with the easiness of using MEL. I just created a circle like I would have normally, and I got this piece of code. Now I can duplicate it, copy it, and reuse it. And this is how I create my circles. I can look up what all of these things are if I need to change it, but I don't need to change it today. So I'll put the circle in the group. Use that with the parent. And then we just need the names of the things. So pillars, control, into control group. That should be it. And I'm gonna move the control group away from the pillars, or where we will create the pillars. So we're gonna set the attribute set the control group attribute translate set to 3. And then I'm gonna select nothing again. Then let me just make sure we're all, yeah. Then I can scroll down a bit. I'm going to create the plane. Let me see where I am. Yeah. This will adapt to. So I use the polyplane. Give it the name guide plane. So here is where we're going to use some of our variables. Yes, I could have just given it the width of 4, for example, but I need the the guide plane to adapt so that to the number of pillars, so that it always matches the length. So if I do 10 pillars or 100 pillars, the plane has the full length of the pillars. So I'm gonna add first a parentheses, because it expects a number, but it needs to do some calculation first. It's gonna take 2 and multiply with my variable cylinder number. If you remember that variable from up earlier, up here, cylinder number. So this is where we get the number of cylinders. So 2 times the number of cylinders will be the width of the guide plane. And then, there you go. That's how we used our first variables, and we even multiplied it. So the height is going to be 1, and then we're going to have the next flag, which is sub deviations x. I think I spelled it correct. If not, we'll get an error and I'll have to look through it. So this is the amount of segments that the power plane is going to have, and I want 1 segment per pillar. So instead of giving a number of 5, I'm again going to give a parentheses, because you're going to have to do some calculations. And you're again going to use the variable cylinder number. I'm pretty sure I start my variables with lowercase, yeah. So it should be this cylinder number, and end parentheses. Cool. And then we can go on as usual. 1 AX 0 1 0. And CH1. There you go. What is next? And I'm going to rotate the guide plane so that it faces me, because I don't want to do anything. I want the script to do it all. Rotate guide plane. So for that I'm going to set attribute for the guide plane, rotate x 90, and I'm going to move the guide plane up, because it will be created on the base of the level at 0 0 0, and I don't want that either. So I can set attribute guide plane translate. Why did I do it like that? Translate y, because I say so. Split joke. And then I'm going to move the guide plane back based on the number of cylinders. Set attribute guide plane translate x to, not a number, because you're going to need to calculate, so you're going to need some parentheses. Going to use the cylinder number variables -2. There you go. And then select nothing. So as I said, this is not how to work with code. I've already, it took me 1-2 days, I think, to figure out what these has to be in the commands. So I have them on my notepad on the left to me. I'm just making sure I'm putting everything right. This is just so that you can have your first script, see how it works, and then maybe change it. And I thought it could be pretty fun. Let me know if you think otherwise, or if you have other ideas, if there's something you need to have explained more. But don't be alarmed, overwhelmed. I can't remember these things in my head. So I do them and copy the code and change it. That is how I've been working with code, and I think it's okay. I think it works. That's what I'll be showing today. So let's create another empty group. rename the group. So it's gonna be rename, and it's gonna have the name null. Gonna rename it into pillars group. There we go. Scroll down some more. Need some more lines. And here we're going to start the loop, or we're at least going to set up the for loop that I showed earlier. So we're going to start with for loop, parenthesis. I'm going to use the variable I, lowercase, to track it, and we're going to say so I equals 0. You're going to start with 0. And then the next one is variable I. So this is when will you stop, and you will do that when variable I is lower than the variable cylinder number, like this. Seems about right. And we're gonna plus variable I for each loop. Should be plus. Variable I for each loop, you're gonna add 1 to the counter, and then when you're done, and then when the cylinder maybe I said that wrong. So start at 0 for every loop, add 1 until the cylinder number is bigger than I. Hope that makes sense. So loop starts here. This is where we're going to be creating the pillars with the locators, with the blend colors connected to the controller, everything. So it's going to be a little while. Okay, so loop starts, and a loop starts with this one here. It even gives at the end. I'm gonna delete it just because I'm following notes, so I don't want to create any errors. So create a cylinder and name it poly cylinder with a radius of 1, height of 1, the 10 in this edge loop, 1 in this edge loop, 1, this can be 0, curves can be 3, CH can be 1, and now the name is gonna be cylinder underscore the number of the loop, so variable I, like this. And I'm gonna move the pivot I'm gonna use the move tool for that. Relative 0, 0.5 and 0, 4, cylinder underscore plus parentheses. So this system here, the way that I'm writing it, will create like cylinder underscore 0, cylinder underscore 1, based on the number of the loop of the repetition. So whenever I need to talk to the current cylinder, I have to write its name like this. And right now I'm moving its pivot point to the bottom. There we go, plus that text, 0.5. Since the cylinder is 1 high, the pivot point will be in the middle. So then we're gonna multiply, I can spell correct, I cannot, loop number by 3 to move the cylinder along a line and not stack. So I want to create a line of cylinders. So for each new cylinder in each new loop, I'm going to have to move it, and I'm going to move it. I said multiply by 3, I actually only need to multiply by 2. So I'm going to create a variable here called move. Variable is $, move, and it's going to equal I actually called it moved in my notes, so I should do that so I don't make any errors. $i multiplied by 2. That way they will create a nice line. Now we move the cylinders. So I will set the attribute for cylinder whatever number we are on. I'm gonna need a plus sign in here, otherwise it won't work. A lot of times when I work, I copy and paste a lot, but if you write it, you will get the hang of it, you'll get the exercise. This can be translate x along the x-axis. And how much is it going to move? It's going to move this much. It's going to move whatever my variable is. And now I'm going to move any history. On the cylinder. It's just always nice when you've moved and stuff. Make identify is the code for that. Or command. Identify. Identity. Sorry. There you go. Identity. Apply is true. And T is 1, R is 1, scale is 1, N is 0, Pn is 1 as well. And then I'm gonna select nothing, so the 2 joints in the next step is not made children of the cylinder. Yeah, we're going to create 2 joints to control, one to control the top of the cylinder, the other to keep the bottom of the cylinder at low. So let's see, select clear, should do that. Let's spell it correctly. Okay. Create a joint at the button. There we go. That's the join command. And I'm gonna create it at my variable moved for the first one, and then 0, 0. And you don't need to be there. I'm gonna have a name, and it's gonna be cylinder underscore plus variable I. Needs to be plus. Then I'm going to call you low joint. So here I'm not going to select nothing, so I'm going to make a note of that. We still have the first joint. I can't spell for it there. Still have the first joint selected, so the new joint will be a child of that. So we're going to create a joint again. The position of the variable moved for the first value, then 0 and 0. Right? Of course it's going to be 1, because it's going to be at the top of the cylinder. Haha. Knew there was something going on. Name cylinder underscore. This is text. This is how you spell cylinder. Plus Jonathan I plus, come on. Gonna call this top joint. And then I'm gonna skin it. Skin the cylinder to the 2 joints. So we're gonna create a skin cluster. And since we're gonna have a skin cluster per cylinder, we should give them some names. The name is gonna be skin number or whatever this cycle has made it do. Yeah, just end like that. And it's gonna be for it's gonna need the name of the two joints. Cylinder like this plus whatever boundary on Dalton 1 plus low joint and cylinder plus I plus 2 top joint and then the name of the cylinder that we made it to. Cylinder yeah, that's just the number it has, but this needs to be text. Then we can finish that, and we are gonna bind the cylinder top to the top joint. And we're gonna do that with skin percent TV. We're gonna have this cylinder that we created. And we're gonna first skin to the top joint, or we're gonna define to the top joint, so we can name this I so for the top joint would be 1. That's how skin percentage works. And then skin, come on, skin plus dot y, and then we're going to define the vertices that are going to have that, and it's going to be these vertices, so cylinder plus revelation depth. So it's going to be dot vertex, and it's going to be from vertex 10 to 19. I think that was the wrong one. That was better. and then just one single loose vertex. We're gonna have that as well. Cylinder plus I plus dark vertex 21. Spelled like this. There we go. Now we can make another node. Bind the cylinders bottom to the low joint, and we can copy this line here because it's probably mostly identical. Instead of top joint, it's gonna be low joint, and instead of 10 to 19, it's gonna be 0 to 9 and a single one of 20. There we go, much easier. We're gonna select nothing, so select clear, and I'm just gonna take a little break. There we go, that was the break. I hope you're following along very well. This is by far the biggest part. We are almost done with the first procedure for the first button. As you can see, remember we just did the skinning. So let's continue and start by getting some space in here. So now we're gonna do, if you remember how, there's gonna be a locator. So we're gonna create that now, create a locator, the green cross. Yeah, true match height. This is the one that will go to the position of the guide plane, and then will blend between the locator's height and 0. So space locator. And if you spell it right, it'll work. And we give it a name. It's going to be locator whatever number plus no, it's just going to be that locator whatever number. That means that this needs to be coded off, and it's going to be at the position of 0, 0, and 0. Move the locator into position. So we're gonna set the attribute for locator plus $1, and then it's going to be the translate y and we can copy that text. I need to write everything. And then it's going to be translate x. That's not going to be 1, it's going to be our moved variable. we're gonna hide it. So instead of translate, it's gonna be visibility. I'm gonna set to 0. Then we're gonna create the blend color node. So that's a shading node. Put the name blend underscore whatever number we made it to. It could be, it's gonna be as utility, and it's gonna be a blend colors node. There we go. And we're gonna set the values for the blend node. So set attribute for blend number whatever plus the color to G, capital G. That's the attribute. It's going to be set to 0. And I can copy that. Instead of color, I'm going to set the blender attribute, but also at 0. Now we're going to connect the blend node now we're going to connect the locator the other way around, locator to the blend. So we're going to use a connect attribute, and we are going to force it, sneaky, and it's going to be from locator whatever number going to be its translate y is how we spell that. And it's going to be connected to the blends whatever number color 1G. There we go. Let's get some space. And then we're gonna connect the blend to the joint. So that's another connect attribute that we're gonna force. Blend whatever number, make it into, there you go, plus whatever number. Oh dear, plus please, thank you. And what do we do now? It's going to be the output. Output G. We're going to connect it to cylinder whatever numbers. Top joint translate Y. I think that's about correct. Then we're gonna set the control for pillar down, because we're gonna do the driven keys now. That's what I'm looking for. So set attribute the pillars control translate X, and we're gonna set it to whatever loop we are on. Then we are gonna set the blend color blend attribute, and this is a little bit of like double exercise, because we have, as you can see, we have set it up here, so we're just making sure that it's the same. This is redundant, but that is sometimes how I work, just to make sure, and it happens, you know, when you're making the things and copying the code for later use. And I mean, doesn't hurt. So we set that, and now we set the, so now we do the actual driven keys. So set the key for driven key. I hope that makes sense. So that is a set driven key frame, right? Yep, like that. And we have a current driver, that is the pillars underscore controls translate X, and then the blend, it should be a name, plus whatever number, dirt blender. And here I'm gonna add 1 to the loop number for moving the control by 1, because that's going to be the end of that's going to be the position for the driven key when the pillar is fully fully visioned. So let's do that. Now add one to the loop number. So I'm gonna take, let's see, I'm gonna create a variable called move2. Not very creative, but it works. And that is gonna be the loop number plus 1. There we go. Then I go move the controller to vision pillar. I hope that makes sense. So I'm gonna move the controller for where I want it to be for the fully vision pillars. So that's gonna be a set attribute not for blend. Come on, getting a little lost in my note here. Sorry. Pillars control translate x to the variable moved to. So now that we have the control in place, we set the blend color. Blend to 1, because that is the attribute we want to drive with the controller. To set attribute, and here we go for the blend 1. Blend plus whatever plus the blender attribute dot blender to 1. Almost done with the loop, and then we just need to finish up a few things, and then we can test the button. So that should be it for the blend. So we can set the driven key, set the second key on the driven key. So it's going to be set driven key frame. The current driver is still the pillars controller, pillars CTRL, and it's translate X. We are gonna drive the blend $sign I, the blender attribute. That we just set, so everything's good, everything's fine. Let me just scroll down a bit. So now the pillars should be created and connected, but then we can just clean it up a bit. So we're gonna put the pillar in the group. One nice clean outliner, that's always nice. So we're going to parent so that should be parentheses, parent cylinder number whatever, like that, in the pillars group. And we're gonna put the joints in the group. So that's a parent cylinder whatever, lowercase I, to that was the joint, right? Yeah. So it's going to be the low joint in the pillars group. The top joint should be a child of the lower joint, so it should be enough with that, and then we can put the locator in as well. Put the locator in the group. So another parent, locator plus $i, and that's all we name them. Put that in the pillars group. Finish like this. The loop ends like this. Almost finished. Finished with the loop. So all of this, where does it start? Starts here. All of this will be repeated depending on how many cylinders and pillars we are creating, and that is of course based on the integer field. So loop ends. Don't have much to do now. Okay, back again. So yeah, the loop just ended, so we're just gonna clean up a little bit, do whatever we think is nice and that we don't want to do. And one thing is put the controller back to 0, because it will have been moved all around the place. So set attribute for pillars control, this one, translate x to 0, right? Yeah. And we are gonna put the guide plane in the group. So that's a parent. Thank you, phone. In pillars group. That's how we do that. Then we're gonna select nothing. So that's a select clear. And if you spell select correct, things will happen. And then we're gonna print confirmation. I always like to finish with some sort of confirmation print confirmation. So I'm going to use the print command, and I'm going to print some text. I'll call pillars created. I'm going to use the backwards dash and n. It's just an old habit, so that whenever I print something, it goes on a new line and not get lost somewhere in between. And then we end procedure ends. So the whole thing, the whole procedure, the whole thing that'll happen when we press the button is gonna end. So I think we should test now, and the first test will show if there's anything here that the script doesn't understand. It'll create an error up here, and if there's nothing there, which would be weird, we'll get our interface, and then we can test it. So let's see if there's anything it didn't get. Okay, there's some syntax errors, to be expected. There we go. Where is the error? Because it starts here. Okay, so we can start having a look at the error at line 83 and at 86. So at 83, see, this is ended, this ends, and this ends. So what is the error? It's a syntax error, so there's something that's not spelled correct. Ah, yes, I see. So it's here, I forgot to put in a plus, so it can add the text, and it's probably the same here. Plus, this is correct, this is correct, this is correct. Okay, let's clear this field, see whatever we didn't get. We actually didn't get an error. Okay, we got the interface. So, can it create cylinders? It couldn't, but I think we see the if. Cannot find procedure make cylinders. So let's just go down to the bottom here, make sure we have make cylinders. Let me just copy that and go all the way up. So this is the procedure. Yeah, it looks like it's spelled like a monkey. So we can just replace it like this. Oh, delete that. That was just for comparison. So now we're sure that they are identical. There we go. That is okay. Can I find procedure rearm? Error line 14. Was what I was trying to say. We can almost see that it's just spelled wrong. There we go. V name. Oh, it was correct. Yeah, because it turned blue. What else we got? Line 14. Okay, still. So no group. Interesting. But that's because we didn't clean the scene, because it already ran through. So if we delete, so we make sure the scene is empty, we go create. Still have one. I can see it creates a null one. That's because there's supposed to be a null one. You see how L and 1 looks exactly the same. So now I'm sure that it's null 1. Great. There we go. We're making down the list. Error 47. No object match name. So what have I not spelled correctly? Probably not one again. Clean the scene. Run a test. Line 56. There's a flag that I misspelled. Let me just have a look. Ah yes, I spelled AZ when it should be AX. Remember to clean the scene. Line 59. Invalid object value 0.5. Really? Ah yes, okay. Well, first off, the pivot should be negative 1.5, and then it doesn't need a value because it already has it. So that was what it was complaining. That's why I created an error. Cleaning the scene, going through it. Error line 80. Okay, this is on the other hand exactly how it is to work with scripting. You get an error, and then we just go through it and see. Okay, I think I can see that there's at some point an L too much in cylinder. That's probably happened more than once. We'll see. Yeah, 83, no object in there. That's pretty. Okay, let's have a look. That's a funny mistake. I don't know how I did that. VTX is how we mention get to vertices, not VRT. So VTX. Thank you very much. Clean the scene again and continue. 83. No match for skin cluster. Okay. So this is an interesting mistake because the mistake is actually not on line 83. It is looking for skin. It's just when we created the skin in line 80, I had an E too much for some reason. So delete, clear scene, go again. 80 to 92. No objects match its name, space locator. Okay. Yeah, okay, here we have the same mistake again, or same type. So it says in line 92, but this line is correct. It's because I didn't finish correct up here with a semicolon. That's why it's creating a mistake. So we'll continue. Continue. Ooh, 125. Getting there. What is the problem here? No object matches name, pillars, control. Is that so? I can see that's actually the translate X because X is supposed to be a capital, right? That's what you say, big letter. Yes, 137. No object matched the name. Cylinder load joint. Oh, and that is because you are looking for the capital C, where I bumped around a little bit and made some of them with a lowercase c. Hey! It worked. Nice. Okay, so about that. So that should take care of the creation of the pillars, the cylinders, and the whole system with the locators. So let's add the function or the button. So I'm scrolling down to my interface here. It says create X cylinders, text set pattern. This is where the button works. So let's do the one where we assign a the sine wave, or any wave at all actually, to the guide plane. I think we called it guide mesh. So as before, we're gonna just make some buttons. One button. We're gonna make a a row with 5 columns, right? Not 3 because it's only one button. So a row, column layout, and the number of columns is 3. And my first column is usually just text, just to have a little bit of space. And we do the actual button width 210. And we're going to give it a label. And it's going to be add sign forward. And let's just make the command add default like this. Did I not? Apparently I didn't spell this right. What is going on with my throat today? So text, come on, space, yeah. That's the end of that, so set parent like this. Okay, so let's see if this creates a button in our interface. It does, and if we click it, we get an error because we couldn't find the add deformer. That's okay. We'll go up here and we will create the procedure. Let's just find it. There we are, okay. So give it a little space and we'll start with a global procedure and called add deformer like this. That is good, but we'll save that for later. So first I'll select the guide plane. I don't think I'll be doing notes for this. I'll be using the flag replace just in case something is selected. Otherwise I could have started with a select nothing and then yeah. Guide plane should be the thing. And we're gonna add a non-linear deformer to it of the type sine. And we're going to give it a name, deformer curve, so that we can, oh, don't know what I'm doing, like this. That way we can change its attribute. I'm not going to set attribute deformer curve, should be like this. Deformer curve, that should be it. I'll set the amplitude 1. Then I can copy, give it some lines. And instead of changing the amplitude, I'll set the drop off to 1. And then I'll set the high bound to 4. And then I'm going to set the deformer curve handle, translate Y, because we have to 20. And I'm still working on the handle, translate X to -3. And now we're gonna rotate Y to 0. Rotate Z to -90. Then I think we're done with the handle, so we'll go back to the curve, copy paste here, because instead of the high bound we'll do the low bound, and we'll put that to 0. Okay, and they come a little in a bit of random order here. We'll set the rotate X for the handle to 0. There we go. And we're gonna move the guide plane, it looks like. To 20. And select nothing. Yeah, and the procedure ends. Okay, so let's test it. There were no error apparently there. Can you create 10 cylinders? Thank you. Can you add sign deform? Can, yes, and there was an error. Let's have a look. Line 169. No object. I get that. Should have been drop off. Just low. There we go. So let's delete this. Clean the scene. $171. Thank you, phone. Let's have a look. Okay, it's because I've messed up the order of D and L for some reason, and because I copied the error. It's always good. There we go. So let me delete this interface. Hey, there we go. Okay, so far so good. But let's finish. Let's continue because we still need the we need the evaluate thing. That's what I call it, we put the locators to the guide mesh. So I'm just going to copy all this because I want another button, and I'm just going to label this evaluate. Did I even spell this remotely correct? I think I did. Cool. And let's just give it the command evaluate as well. So I'll go up where I have my procedures here, and I'll start my evaluation procedure. So that'll be a global procedure evaluate. And this will also need the for loop that we had. So we're going to base this on the cylinder number, or the number of cylinders. So we're going to make a variable called cylinder number equals this little dot sign here. Int field. Going to use the query flag to guess the value for cylinder field. And then we're going to make a for loop for, let's say, $i equals 0. So that's where we start. Like this. And then when $i is smaller, come on, slow I, then variable cylinder number and gonna add 1 per trip. There we go. Okay, so we start the loop like this. And we are gonna get the vertex position for each vertex. So let's call it vertex position. Create a variable of that. Vertex position equals, come on, transform. We're gonna query, we're gonna ask, that's how you spell it, TWS. Then it's gonna be for the guide plane vertex ETX is how we do that. It's going to be number whatever. So you're going to use the for loop cycle. It's going to be the for loop cycle. Since we start with 0, it's going to be for loop cycle number +1 +1. This, and then we're gonna add the last text, which is to close off the bracket. There we go, and then finish with this guy and this guy. So I hope that makes sense. We're going to get the vertex position using the transform command. This is why we have these extra signs. And we're going to go for each vertex of the guide plane based on the for loop number +1. So we're going to get a different vertex every time. And then we move the locator to that position. So we're going to transform again. We're going to translate, which means to move. And then it's going to be this here as the X position. Or we're going to use this. So let me explain that better. Here we use a variable. We ask for the position in the world space, the translate of this vertex. So this will give us an array. This will give us 3 numbers. So that's why I can now say, okay, for this array, this package of 3 number, I'm going to put in 3 positions. Like if I just wanted to put transform 0, 0, 0, it'll put us at 0. But I'll put the first value of this array, and that is 0. That is how programmers count. I can't help it. I didn't do it. So it's going to be this for X, and then it's going to be this position. So the 1 for Z. No, sorry, X, Y, Z. So a Y, which is up in most 3D software, and in this one, and then 0 for Z. We don't really have any movement in that. And we're going to do it for locator, whatever number we made it to in the for loop. So I hope that makes sense. And then we're going to end the loop because and it already has, right? Yeah, loop stop, loops end, and that the procedure ends. And I guess we can just finish wipe with a print. That's always nice to have a confirmation print. So print evaluated on a new line. There we go. That should be it for the evaluation. So let's have a look. No errors. Oh, don't have an empty scene. Now we do. Why is that the last button we're creating? I don't know. There we go. And you're adding deformer, but they aren't doing anything. Now we evaluate. We have a mistake. Let's have a look at line 188. Once again, it's my clumsy spelling that gets the best of me. Cylinder is with the N before the D. So hopefully that does it. Let me clean the scene. Actually, I shouldn't have to clean the scene. I should be able to keep evaluating. So let's do that. Evaluate. Hey, it went through. It didn't work. Haha, it did. Cool. Let's add the last button, which is to reset the scene. So to keep the order that I have a little bit, I'm gonna have the last button here down at my interface. Just gonna label it reset scene. And the same for the command reset scene. There we go. And let me go up here so we can create the procedures. Where is my reset procedure? Here it is. So a global procedure, and it's going to be called, we call it reset scene, right? this. So I'm going to start by selecting with the replace flag everything. I'm going to use this asterisk here that had the word blend underscore in it, and then doesn't matter what's before and after. I'm going to select that. That's to select the blend color nodes that we create when we create one per cylinder. So I'm going to select them, and then I'm going to do delete. Like that. That'll delete it. And then basically we're going to do a lot of that when we reset the scenes. Then I'm going to select the control group like this. Just copy my code here, delete that. Then I can select my pillars group and delete that. And that's actually it, I think, yeah, because we have the blend colors, and then we have control group. I'm pretty sure that the former handle will delete itself once we have the guide plane. So let's run this, see if it works. Didn't seem like it mattered. There we go. Wow. Does it work with 20? There we go. Yay. And I can take this and I can go the offset. Now they don't work, but if I evaluate, they do. Look at that. Hey, it worked. And we're finished. I hope this was useful for you. I hope you had fun. Hope you have the you feel motivated to try and script whatever you do on your own. If you have any questions, any comments, feel free to post it. I'll have a look at it, see what I can do. Good on you for hanging out there. That's my first tutorial. There'll very likely be more because I like doing this. Thank you for watching.